Question number 5 is a quadratic inequality. You can kick this off with red dudes, but at some point you must use a graph. So anyway, here I go. What I can do is graph that and ask myself when it's higher than a height of 5, but probably simpler is to do this. That and that differ only by one red dude. So now graph that and ask yourself when it's higher than the x-axis. So the graph of that, loads of ways to graph that. Could graph it by calculus by working out where it's flat, but I'm not so interested where it's flat, I'm interested in when it's higher than 0, so graphing it by intercept would be the best, I think. So graphing that, intercepts come from making y equals 0, that gives you the x-intercepts, and never any excuse for not doing a y-intercept, because it's so easy just to put x, make 0 being x. So that's your graph there. Now when is that higher than 0? It's higher than 0 there and there. So converting that to the language of the question, which, so in other words, x values. The x values are not cool there, not cool there, not cool there. Why? Because it's down low there, and it is cool there because it's up high over there, and it is cool over there. So the answer is x is greater than 1, or x is less than -5. Remember, these fellows don't count because we wanted it to be higher than the x-axis, not lower. If the question had been this, that would now be the answer, and there would be ticks there. Oh, sorry, about 30 seconds ago I said higher, not lower. I meant higher, not lower or even on the x-axis. So that's question number 5. I'll just check I got the answer for that right. Yep, I did. Question number 6. So we're given the gradient and we have to find the equation of a curve. So it's like we're given the second line of a multiple choice box and we have to come up with a top line. So this will be an integration question. The role of the 3, 0 is to help us know what the c is. So here I go. So second row, top row, 2 would have come from 2x, 2x would come from x squared, and of course there's a plus c. So if y equals 0, x equals 3, there you go, that's your answer there. So that's question number 6. Just check I got that right. Yep. Question number 7, we have to show that 2 lines are parallel. Well, your grip on the parallelism of lines is to check out their gradients. If they have the same steepness, then they won't be able to intersect with each other. So how do you show that they're parallel? So how do you find out the gradients of those 2 lines? Well, you could graph them, but it's probably simpler just to make it fit the y equals mx plus c template from year 8, because as long as y is by itself, when you're careful about what's being added and what is independent of x and what is multiplying by the x, then the m will be that multiplicative constant there. So y equals 4 minus 2x. I'm being super careful. So the m for that is -2. What about the other one? 4x plus 2y equals 5. 2y equals 5 minus 4x. Y equals 5 minus 4x over 2. Now being super careful to compare it to the template. So that's the answer to Roman numeral part 1. Roman numeral part 2, find the equation of the line which is perpendicular to these two. Now to do that I use the Year 8 template. For Roman numeral part 2, the Year 12 add mouse template is so much better. It's this. So good when you not know that a point that it goes through. And the m, if it's perpendicular to these, will be a half. Perpendicular lines have to have gradients, whatever it takes to make them multiply to give -1. In other words, one has to be the negative reciprocal of the other. You tidy that up. And that's your answer.